Welcome everyone to this first EECONE project webinar. This webinar is dedicated to introduce the project, its objectives and main contributions. It is organized in two parts. First, we are going to present to you the project, and then we will answer your questions in the second part of the webinar. If you have questions, please place them in the question and answer button that you have at the bottom of your screen, and we will provide answer at the end of the presentations. Before to start, I would like to thank Design and Reuse for the technical support, and more specifically Arnaud Serra, who is working as a software engineer. I also would like to thank a lot all the speakers for today, all work package leaders in the EECONE project. Thank you for preparing the contents you will share with us all today. Well, I propose that we start now with the big picture of the project with the introduction from Moritz Schlagmann. Moritz is with Infineon Technologies, working on research and funding project. He is co-leading the EECONE project with Wolfgang Dietmann. Moritz, if you want to start, this is all yours.
Perfect. Also, a warm welcome from my side. I'm very happy to present the first EECONE webinar here with you. And I would directly jump into the challenge that we have. So every year, you don't have to remember the numbers, but every year, the generated e-waste is increasing and increasing. And the problem is that, on the other hand, the recycling and the proper collection rate is not growing in the same way. So we have almost a factor of 5 of growing e-waste, while our collection and recycling is not anywhere close to it. And this problem we want to tackle here within EECONE. It is really a global problem. It's not only a European one. And what we can see here is that it is especially important for us because we in Europe are producing a lot of e-waste, and our recycling rate is also not anywhere close where we want to have it. So with the EECONE project, we want to develop the technology for a zero waste future of electronic components and systems. And it's a big challenge. And how do we want to do it? We are guided by the 6R principles that are also in our project logos, which is reduce, reliability, repair, reuse, refurbish, and recycle. And guided by these principles, we are tackling it with our 4 key objectives. First, obviously, we want to make green electronic components and systems. So we want to make advancements, we want to develop innovative techniques for the 6R principles. Then we also want to showcase it. And this is why we are also doing this webinar, to introduce it also outside of our project and build then in the next steps consciousness. And last but not least, we want to also define what are green ECS, because if you just talk about it, it's easy to say we are green and we are doing green stuff, but having a deeper look into it and understanding what is green and how can we contribute to it is very important to us. And who are we? We are the EECONE Consortium. We are over 50 different partners from all over Europe. Many of the speakers that you see here are from France, from Dassault Systems, ENP, from Recycling, KLA, and we are working together with large enterprises, as Infineon is, with small enterprises, and with research institutes to tackle the problems from different sides. And we are working also from different areas and different areas of expertise on it. So we are looking into LCAs, we are looking into eco-design, we are looking into the materials and processes to improve them. We have partners that take care of applications that you find in the automotive industry, in the consumer electronics, in the ICT business. We have the manufacturers of electronic components and systems, and we are having also end users like reuse and recycling companies, as well as data science and data management tools here. We want to showcase the results of our work in 10 use cases from 6 different areas. The first area is, as I said before, the automotive area. It's about electrical control units in cars. It's also for electrical cars about inverters, onboard chargers, DC-DC converters. Then coming to consumer electronics is about membrane switches that you can find anywhere. You can find it on doors, and you have maybe pressed it already today and not have thought about it, but we want to also improve these ones. We learn about eco-design of remote controls. We look into the home appliances. On the health side, we want to make point-of-care sensors that you can directly bring into or use it on your own or bring to the patient, more sustainable. Coming from a different field to communications, we are looking at data centers, we are looking at ICT user equipment. So basically, how can you use your smartphone longer, and what could be a second life or an extended lifetime for your smartphones at home. We also have partners in Italy. They are looking to improve the aeronautical developments of planes, and then also agriculture. And then coming to our today's talk, this work is structured in a way that we have 4 main work packages: management of existing e-wastes, where we take care of what is already there and what is the end of life. We talk about new generation of electronics. We talk about tools and techniques, how we can generate them as well. And then overall, everything contributes to our ecosystem building. And this work package is led by Jean-Christophe. So I would hand over to you again.
Thank you, Moritz, for this big picture of the project. Let's now focus on the first technical work package with the presentation of Mélanie Bunel. Mélanie is with Recycling, a key player in the electronic waste recycling industry. And Mélanie is international project manager, and she is leading the work package too. Mélanie, if you want, it's all yours.
Thank you, Jean-Christophe. I'm going to share my screen. Tell me if it's okay or not, okay?
Yes, it's okay.
Normally you should be able, okay. Welcome everyone. Now we will explore the work package 2, which focuses on managing existing electronic waste. The goal of this work package is to explore solutions to manage e-waste and increase the circularity to minimize the carbon footprint of electronic industry. To achieve this objective, we are targeting 3 key areas. The first is repairing, with an objective to increase the repairability rate of electronic products to 60%. The second is recycling, with an objective to align with Europe's ambitious target of an 80% recycling rate. And the last key area is the end-of-life oriented eco-design, with an objective to creating eco-design guidelines to address repair and recycling limitation, helping manufacturers build more sustainable products. Together, repairing, recycling, and eco-design form the backbone of the transition to a circular economy across the entire life cycle of electronic products. This work package directly supports one of the EECONE goals, which is make green electronic industry, with the aim of provide innovative techniques for reducing, repairing, reusing, refurbishing, recycling to decrease electronic waste and boost circularity in a new generation of electronics. So now let's dive into our first focus, repairing. So the objective is to be able to answer to the question how to extend the lifespan of electronic devices. We work on 4 key tasks to do that. So the first is to work on the comprehensive repair guidelines. We are developing a practical, which is a detailed guide to empower individuals and professionals to test, diagnose, repair a wide range of electronic components. This resource will help extend the lifespan of countless devices. The second objective of this task is to work on imaging a collaboration with an online platform where used electronic components find a second life. To do that, we would like to reach a digital marketplace which will facilitate the exchange of pre-owned functional parts, reducing waste and creating a new business opportunities. Then the third objective of this task is to work on a partnership model between manufacturers and certified repairers. And the last one, which is very specific because it focuses on data center and ICT equipment. This last task is to collaborate with the use case 7. Strongly connected with this use case will help us to work on developing on refurbishment programs to extend the lifespan on ICT equipment. So this is the first task of this work package, working on repairing. So now, just to conclude of this first task, why focus on repairing? This will allow us to reduce the need for raw materials, energy consumption and waste generation, create jobs, support local businesses and spark innovation. And also because electronics will last longer and it will benefit everyone and align with global sustainability goals. So let's continue with our second focus on recycling. The recently adopted CRM Act, Critical Raw Material Act in 2024, highlights the urgency of securing raw material supplies, and it identifies 34 critical raw materials essential to modern economy, but at risk of shortages. So in this second task on recycling, our focus area are to work on mapping material flows, inside the electronic industry, to be able to see where we can find these raw materials around the supply chain. So this will allow to work on prioritizing critical metals. And for the moment, we are targeting high demand material like copper, silver, or tin, for example. And we also focus on rare elements like gallium or germanium, which are vital for semiconductor. This investigation will allow us to work on recycling scenarios, and we will be able to develop new technology to recycle and to improve our existing technology. So why does this matter? So it will allow us to reduce dependence on foreign suppliers and mitigating supply chain risks, also to conserve resources and minimizing the ecological impact of e-waste, and also the circular economy for critical material will open new businesses opportunities and promote sustainability. Finally, our last task, which focus on repairing. So we are working also with our partners on their electronic product, and specifically on the eco-design oriented end of life. Okay, so about repairing, we are developing a tool to assess and to score products based on their real repairability, helping manufacturers identifying design improvement. Like this one you can see on the screen. This is a diagnostic with a notation from A to E to be able to see if the electronic products are well repairing or not well repairing. This will offer actionable insight for creating products that are easier to repair, disassemble, and upgrade. The same thing is done for the recycling part also. To improve recycling efficiency, we are addressing design constraints that hinder material recovery. We are working on recyclability matrices. We evaluate the products based on material composition, assembly method, or hazardous substances. And we are developing eco-design guidelines, which are under creation right now, which focus on 3 specific criteria: the dismantling parts, by evaluating the difficulty and the rentability of dismantling; the material combination, which focus on how the combination of certain materials can affect recycling process. For example, nickel might be a constraint to extract the other metals. And the last one, the material separation. We work on how the intrication of materials like plastics and metal, for example, might be a problem to separate the material. In that work, we incorporate indeed the measures to protect recycling technicians, and we address also hazardous material like mercury and lead. Thank you.
Thank you, Mélanie. Let's now continue with a work package dedicated to data, tools, and indicators for circular electronics, with the presentations from Chiara Sandionigi and Olivier Pedoussaut. Chiara is with CA. She is Senior Research Engineer, co-leader of WP3. And Olivier is with Dassault Systèmes. He is Solution Experience Director, co-leader of WP3. Chiara and Olivier, it's for you now.
Thank you, Jean-Christophe. So here we will see how to take into account the 6 R of EECONE when designing new electronic components or systems. So we can deal with the reduction of the waste at 3 main moments of the electronics. The component or system can be a waste, or it can be a product that entered into the market, or it can be a design. And different R strategies are associated to each moment. In the figure, you see a list of R strategies, including the 6 targeted by EECONE. So the management of the existing electronic waste and the lifetime extension of the existing products are 2 of the axes of work of EECONE. Here we focus on what we can do at the design level. Our first strategy is to assess the environmental impacts and evaluate the design options to reduce them. Nevertheless, this strategy alone is not sufficient to reduce the e-waste, so at the design level, we also need to anticipate the circularity strategies, and this is one of the challenges of the project. Targeting the design phase, we inherit some challenges from the traditional approach. First of all, we know that electronics constitute a multi-level domain, as we can work at integrated circuit level, at PCB level, at system level. Moreover, it is also a multidiscipline domain with multiple expertises, because we have different engineering teams that often work in silos. So these considerations already apply to traditional design. Now we are introducing new parameters and constraints, and we see that there is a distinct disconnect between design space and environmental space. This makes environmental impact very challenging to assess, and the 6R, which we consider crucial to achieve environmental sustainability, usually these circularity strategies are not supported by appropriate metrics during the design of the system or components. One of the project that we deal here is to provide tools to design electronic components and systems. where we must take into account the R strategies, so the circularity strategies. It has always been true that tools both limit and drive research directions. It was true when the design paradigm was mainly driven by performance, power, and area. It is even more challenging today as we want to introduce environmental assessment and a circularity strategy. Besides the single tools, we aim at creating a global framework to help producers in the evaluation of the design choices. So, to achieve our objectives, we work on 4 main points. We have the metrics, the tools, the platform, and finally the guidelines. The tools we are developing in the project must be driven by metrics that quantify the 6R. One of our first actions as a consortium has been to have an internal survey about the metrics related to the 6R. We collected about 100 metrics. This work allowed defining a preliminary state-of-the-art of the existing metrics, and also it allowed identifying the needs for new metrics. The metrics collected cover 2 purposes of the design of electronics. A first purpose that we define global, it is the quantification of a parameter of interest, and a second purpose that can be defined as more relative, that is about the comparison of design. So just to see an example of a new metric that we defined in the project, that is for the comparison of design. So we identify the needs for new metrics, and an example of metrics focuses on the strategy of reliability that is considered jointly with the strategy of reduce. For the objective of material efficiency, the reliability of electronics becomes mandatory not only for the usual safety-critical applications, but now it is for every system to guarantee the first life. Nevertheless, when we consider reliability alone, reliability is a probability. It is defined as the probability that the product functions as required under given conditions for a given duration without a limiting event. Reliability techniques actually have an influence on the first life, but they also introduce overheads. So in a perspective of environmental sustainability, we need to consider jointly reliability and the impacts on the environment for both the production and the use. And we also need to take into account that we live in environmental limits. Here we proposed a new metric called eco-reliability to help the design of electronic components or systems. The objective is to maximize the reliability while reducing the environmental impacts. The main objective of this metric is the quick comparison of different designs of a same electronic component or system. And the metric also allows comparing different electronic products for a quick positioning of their environmental sustainability. Now I let Olivier present the eco-design platform, which provides a set of complementary tools and where these tools can be connected or work in a standalone mode.
Yes, and through this eco-design platform, we have created an all-around catalog of 12 tools so far. It's like a Swiss Army knife addressing our eco-design needs across, and it's important, all levels, integrated circuits, PCBs, and system. As Chiara mentioned, we are multi-domain, so it's important. Those tools collectively are supporting the EECONE 6R strategies and use cases, and we're offering a comprehensive and flexible approach to advance sustainability in electronics. In the coming 5 minutes video, we will illustrate one of the 10 EECONE use cases articulated around the green soil probe developed by TST, or we use the 3 Experience platform as an example. But while these demonstrate a specific approach, our platform offers other tools and metrics that allow us to address additional aspects of eco-design. The goal being to ensure a comprehensive strategy for our creating more sustainable product in electronics. So let me share the video with you.
Olivier, we don't see you.
Yes, and that was because I was running the video, so I was thinking it might be better that you can actually see the video. I think it's better to see the video than my face, but I will switch on the camera just after the video if you don't mind. So just let me start the video. So here we are showcasing how EECONE 6R principles are integrated into a standard design process platform, enabling the collaboration between the designers, LCA experts, and more. Within a single environment. We try to combine design insights, weight distribution analysis, LCA, ensuring that every stakeholder collaborates, creating a more sustainable products. It starts right from the concept validation phase, where our 6R principle guide us to explore innovation and sustainable solution, like here optimizing the battery recycling process for our product. We can also capture and document the insight we gain from these studies, sharing this knowledge with the entire community. This fosters synergy and build a collective intelligence. It's important that we are a collective intelligence with all those different roles, enabling us to address industry challenges and create a more sustainable product, but together with all those different, as you can see, we go with all detail. And so this product inside help us identify the optimal components for our design and efficiently build our BOM, bill of material. The platform allows us to go from highest level, system level, to the detailed component data sheets, as you can see here. We ensure that like this, we are streamlined from design process. The BOM is paired with the 3D representation, so we can intuitively visual the pinpoint, the design issue affecting our products. When it comes to explore alternative, we can compare different design choices through 3D or through the product structures. Allow us to dive deeper into the different design options and identify the optimal balance between functionality and sustainability. We can go further by analyzing the product's weight distributions to identify which component contributes the most. Since reducing e-waste is our primary concern, minimizing the overall weight of the product can be a crucial step toward achieving this goal. So as you can see here, we navigate, we see the bare board, the temperature probe, the battery, so we can already navigate and see in 3D the weight distributions. Once again, the weight analysis is not limited to a single product. We can compare different product design and highlight the improvement achieved. Here, of course, it's a very simple case. We just compare two battery options, but we can apply the same approach to a more complex scenario. And we hope to expand this in the coming years of the project. Here, that's a clad resistance, piezo resistance. We evaluate the environmental impact of our product. We're leveraging the knowledge we have on the bill of material and the weight data, and we can quantify the environmental burden of each component. With detailed information from the EECONE database, we can assess our product performance across 16 environmental metrics, including carbon footprint and water usage. These tools not only support informed decisions to enhance sustainability, but we can visualize hotspot directly in 3D for a clear understanding of the impact area. As you can see here, so we have overall for the different metrics, but also per human activity with the key impacting human activity. For the PCB and so on, they are also revealed in 3D. Market for copper, market for battery, and also all those information can be revealed as well in 3D too. Just if you have the expertise of the LCA practitioners, but it can be understood by a designer as well. And see the distribution of the life cycles. It's a holistic approach of the product's life cycles. Once assigned to a product, EECONE activity are transferred from one product version to the next, so we can rapidly evaluate and compare environmental impact across multiple versions. For instance, when we explore different material options, we can focus exclusively on the data. We update only the new activities that differ between versions. This way, we can ensure consistency in our life cycle assessment. As mentioned earlier, we address all 16 metrics of the product environmental footprint. Once the assessment is complete and shown here, we can publish a report to share with our community. It's not as detailed as a full environmental product declaration, but it's a first way to engage all the stakeholders in meaningful discussions and collaboratively explore solutions to mitigate the impact that we have identified and that we are highlighting here. So it's a very collaborative, important, it's a collaborative process between early from the conceptions, early in the product design, as Chiara mentions, and this is really an important collaboration between designers, practitioners, and all people involved in the product design in the life cycle phase of this product. So that's all on my side, and as you made, hello, you can see my face now.
Thank you very much, Chiara and Olivier. Let's now jump to learn more about Work Package 4, dedicated to more sustainable technology development, with the talk from Elyakim Kassel. Elyakim is with KLA. He is coordinator of European projects for his company, and he is leading WP4. Elyakim, it's your time.
Good afternoon. Do you see the presentation?
Yes.
Very good. So the Work Package 4 is a very interesting work package. It's the largest in the project, so it's covering a lot of topics. It's called New Generation Electronics, and it starts to approach solving the e-waste issue by making different electronics. And we do this at all levels, at material level, at component level, at system level. And we are organized in 5 tasks. Each task is itself could be seen as a little work package. So I will go over all of them, giving an example of achievements and what is the importance of each of them. And just to mention, because Work Package 4, as I said, is a very big, so it's intersecting with all use cases except use case 5. And here also we see a matrix how each task in itself is intersecting with the use cases. Now, I'm starting with the first task, which is low environmental impact materials. Let's start to look at new electronics, new generation electronics at the material level. And we took the PCB manufacturing as a test bed, and we are looking at new conductive inks and substrates. And the goal is by 2030 to have a reduction by 30% if the current electronic is replaced by the new developed electronics with those new materials. And so we started with new conductive inks, and we took 2 directions. One has to do with the graphene base, and you have a picture of it. Graphene, you know, it's a carbon type material, so that's why it's all black. And we're also making new inks of copper. We are also, and that's part of Work Package 2 in a certain sense, also looking at using recycled copper inks. So this is also something that could serve our purpose. Regarding the new substrate, we decided to look existing new substrate, not to reinvent from scratch materials. So here's 2 examples of how to say environment friendly potential substrate that will be better than what is currently used in PCBs. And we are already on the printing test stage, and the top picture is copper. The bottom 2 pictures has to do with the graphene, and we are printing and testing and getting results and making progress on this important task. The second task is a task which says, okay, we want to reduce the e-waste. Maybe let's do our electronics with less material to begin with. And that's a very important approach also. And we are doing this across the board of designing the new electronics. It can be on the component level with the substrates that were already mentioned, and the integrated circuits themselves, inks, magnetic components, membrane switches, all those things, to start with less material to begin with. And also at the system level, we have many applications that are found in the different use cases, and in each of them we try to do less material. Now let's look at two examples of what we've done. This is a design of a new chip with a very clever energy management unit, and the idea that if we can better control energy consumption, we can reduce the chip area and the waste, and also smaller signals we process. So altogether, we have less functionalized material, and we can make the chip smaller. Here's a totally different approach. If we are looking at making the density of lines on a PCB higher, so we will have smaller lines and densely packed, and in some cases to keep the manufacturing yield. So we'd like to be able also to repair and not throw away certain things. So that's an enabling technology for denser lines. We are developing laser-based approach to remove excess copper, creating shorts. That's the left-hand side picture. And we are also adding, where needed, copper, and this is the opportunity to repair opens or disconnects on the right-hand side picture. Now let's move to the next task, which is second life to electronics. The idea of second life is when some electronic system or component ends its life, either or instead of just throwing it away, trying to provide a second life. And there are different approaches. One approach, this is good for chip, is to be able from inside to monitor the life cycle of the chip, and we know exactly when it is ending its first life, and when we can refurbish it and start a second life and still keeping it to a good reliable level. So that's an important tool that we are developing all together, and we see this in different examples, that modularity, that the end of life may happen because some critical parts stopped working, but other are still good, and we would just repair that critical part, so we could have a second life for the system. So it's important to have a modular design so that we can just replace what needs to be changed to have a second life. And here, for instance, this is an example of taking some electronic cards and being able to desolder and clean and reball and replace just the part which failed, and then we can provide a second life. And now I'm going to the 4 tasks. Okay, we said, okay, let's start with better material, and then we said let's at all put less material. Then we said when the lifetime and when the product gets to its end of life, let's try to provide a second life. And here we have an effort in the task 4 to make the lifetime longer, so that we don't have to throw the electronics so soon. And there are many also approaches. Also, the modularity is part of it. And if we use this is an example of with a programmable logic into a system on a chip, and if we use the proper programming version, we can make the lifetime longer. Or here, that was the example of the membrane switch. We know the killer is is a silver migration. So if we work on improving the ink formulation and printing, we can make the lifetime longer. Now, this has to do with our last task, which has to do with to improve the recyclability of small battery packs, so that we don't have to throw away when the battery is finished. And it's a very problematic topic, because now batteries are everywhere. So we work very much on the recyclability, and the first step was to really look at what we have inside the those battery packs and separate into different types of material. And we work on this, and this is the starting point of recycling in a sense. And we also have in this task a plan to improve also the materials, taking some of the ideas that we mentioned in task 1. So that's all what I wanted to share with you in that work package 4.
Thank you, Elyakim. I will now start to present the last part of the last work package of EECONE project. So my name is Jean-Christophe Crébier. I am CNRS researcher, and I am leading this work package 5, which is dedicated to ecosystem building. So basically, we are organized in the 5 main tasks, which are quite usual for dissemination, exploitation, and regulation. And we have also 2 more specific tasks for this kind of project that are original and dedicated to work on the ecosystem building. One is related to education, and the other one is related to survey activity, where we try to map the ecosystem to understand the practices and things like that. So what I will do to conclude our presentation is I will just provide 2 short focus on these 2 tasks, the other 3 tasks being more, I would say, regular and classical. So regarding the survey activities, this is what is the big picture of our objectives. We want to map the circular electronic ecosystem. We would like also to identify education needs and offers in order to support the specifications of the education activity, and as well as to create the links between needs and offers. We want also to work on to map, the new business and how can be implemented the economic transformation toward circular electronics. And we want, of course, to gather and identify all the knowledge and resources that are already available in circular electronics. Of course, also we know that our partners working in WP2, 3, and 4 are also running technical surveys, and in WP5 we will try to also take advantage of all this work to aggregate all this information and make it available to the community. For example, I will just provide here a short illustration of a question we have placed to our community, where we are asking them to tell us in which 6R approach their team is involved. And you see here the results of the respondents. And what we can see is that Reduce, which is one of the 6R we are working on, is the most popular activity in which the question in which the people answering are involved. And on the other side of this plot, we can see that refurbishing is on its side the least option that is selected by the professionals. So this is just to show this distribution with at the middle big contribution and big activities in reliability, recycling, reuse, and repair. Of course, We have placed many questions. We are running many more surveys, and some more data will be displayed over the project. And we are planning to run a webinar pretty soon on this topic. Regarding the activities related to education, one of the topics we are working on is actually to identify what are the offers and to make links between people looking for trainings in circular electronics and offers in circular electronics all around Europe. So we are developing a tool which is named Atlas, and that is going to be, it is under the development and is expected to be made available during 2025. This will help, of course, people to ramp up in their knowledge for circular electronics. We are also currently developing education content and events. Those contents will be made fully accessible and fully adaptable for anyone who wants to teach or to learn more on circular electronics. And we are about to announce the first summer school in circular electronics that will be organized in Grenoble in France in June 2025. This event will, of course, be an opportunity for EECONE partners to showcase their development, their innovative technologies and tools. We are planning to run this summer school in partnership with another European project, which is dedicated to developing education content for green electronics. I think this is it. I think it's important before to start looking at the questions that have been placed to thank our funding European and national authorities for the support they give us to run this project. And here it is a CHIPS GU project that is supporting us for this. Thank you all. I am going to give now the word to Moritz, who maybe has a chance to take a look to the questions. Do we have questions?
Yes, Jean-Christophe, thank you very much. We have one question. Many times I was asked if the screen was shared. Yes, the screen was shared. So we figured that out. Then another question was, does Infineon currently handle end-of-life products in power modules of automotive or renewable energy industries? So I guess that's right away a question for me. Infineon is focusing at the moment on sustainability on their side, what we can really do about it. So we are focusing in making the production greener, making our products more reliable, reducing complexity and making it more sustainable in that way. Usually we sell our products then, for example, in the automotive industry to tier 1 suppliers like Vitesco, Schaeffler, or Bosch, and they using it then, they bring it then into the cars, into the OEMs. So at the moment, we don't have a direct influence on them, and we don't do it at the moment, but we are working on it also in use case. One, for example, on components, how can we desolder them, reuse them, and in general make the inverters and the power systems more recyclable. So we're working on it. It's under research, and it is a very valid question. So thank you very much for that.
There is another one.
Okay, then what could be possible channels to start the end-of-life products to align them back to the 6R methods? So I guess, Mélanie, you have had a look into the disassembling from an inverter. Maybe on this example we can provide something.
Yeah, thank you for the question, Moritz, and the person who has the question. Yeah, indeed, we are in the work package 2. We work on the end-of-life projects, and we are analyzing how the current electronic products on the market are easy or not to disassemble, the first thing, and how they can also be easy to recycle. So we work on a recyclability matrix, and we analyze each part of the product in terms of components and in terms of composition to see how it is possible to make them easier to disassemble and easier to recycle. Because we really would like to introduce the end-of-life products in the eco-design. So we would like to push the manufacturer to take into account in the design of their product since the beginning, the managing of their product at the end of their life. This is what we are currently doing in this project.
Perfect, yeah. Olivier and Chiara, you are also working on a new generation. So with your tool sets, how can you really from the beginning think towards the end already, having the end in mind? Oh, you're muted?
We hear you.
Yeah, that was on mute, sorry. So far, we have not yet explored. We have the capability to do so. We're just focused on the design engineering part of the product life cycle. We didn't showcase this in the video, but we did some simulation on the remote control. So we explore that aspect, but we have the ability to simulate the disassembly process as well. So we have the tools and everything. So we could go that far to actually assess, and we can also assess the impact of the disassembly process. Like you've seen on the product structure, we could actually simulate the disassembly of any of the products we studied in those different use cases and assess their environmental impact and assess their level of, I would say, reparability directly within the platform. So we have this ambition, but right now we did not go that far.
Yeah, it's a challenge, but yeah, you are really addressing it already. Jean-Christophe, if you think about it from an educational side, how are you addressing, or how do you guide students towards the 6R principles? What is your focus, maybe?
I would say that we are still at the beginning here. So what we do right now, we are making them sensitive to all the methodological aspects linked, for example, with the assessment of the environmental impact, which are mature methods, but still they need to gather how to implement this and what are the limits, how to get access to the data and things like that. So today we are engaging our students on this path. Regarding the actual implementation of the 6R, this is still mostly front of us, I would say, since we could address it a little bit from the theoretical point of view, but from the practical point of view with labs and things like that, at the moment we are still developing this, and we are actually not running a clear practical teaching on this aspect. So it remains more theoretical, where we present, for example, design guidelines and things like that, and tools and methods to assess, but not so much actually on the circularity options.
Mm-hmm.
At least from what I know from my side.
Mm-hmm. Because you're also teaming up, getting the educational programming running in cooperation with the other EU projects. So
yeah, we are on our way, but it is
Mm-hmm.
still not already in place.
No, absolutely. Yeah. Yeah, that was a nice comment. Thank you also. Thank you for the useful information presented today. I've learned a lot from the today's session. So yeah, that was really our intention here to share the knowledge that we gain and make everyone aware of it. And it is a very important topic, and we are happy to provide you this information.
There is also a question, I think, for Olivier. Is it the one that with SolidWorks, something like that?
I cannot see the question. If you can read it and share it.
Very interesting talks, thanks. I have a question to Olivier regarding the tool in 3D SolidWorks. I am wondering, as you have a lot of different components in SolidWorks, how can you connect it to the limited amount of data values in the EECONE database?
That was one of the tricky challenge, and I think that's why we're studying all the database available. This is also part of the work package 3. This was a challenge, so we need to identify some proxies when we don't exactly have the information in the EECONE database. We try to find some proxy to make an assessment as, I would say, accurate as possible. Of course, there's and we had our tolerance in terms of the assessment we are making. So at least, like I said, it's important we have a consistency in the assessment we make for the different design options or different versions. But we are, unfortunately, as you mentioned, as good as the EECONE database is, or maybe we can rely, we have other partners within the consortiums, like IMEC or other companies that can provide some information for those components. In the Eco Design remote control with 4Mod, it was a little bit, I think, too late to benefit of some information regarding the manufacturing process, the impact of the manufacturing process of some of the components that IMEC could provide. But actually, we have different ways to assign this impact. Of course, we use the information. The first one is the information coming from the EECONE database. We can also directly enter information that could be provided by IMEC, by example, on the manufacturing process, as mentioned, of some of those components. So we can directly enter those, or we can create some custom activities if we have the right formulate based on the component weight, and we can make. So we all have those information to make our assessment as accurate as possible. And like I said, at least even if it's not really accurate, at least this is consistent between the different versions, and we are actually comparing the same things, and we measure the same impact from one version to another. That's where we had at the moment. But that's a very good remark, and it's totally valid.
Absolutely. This is, I think, one of the biggest challenges, and that we see here that we still need a lot of information from all kind of players. We need from raw materials to the manufacturers, really contributing everybody from IMEC towards SA data about chips and semiconductors. And then if you can bring it all together, then we have the biggest chance to have the whole picture. And it is the challenge that we're currently facing.
And the positive point in what you're mentioning, like I said, Moritz, is we have ways, if we get this information, and that's a challenge still, to get the proper and accurate information, to enter this information in the assessment. So for some, and that's why it's important, we have it's a multi-level, so we have the system, the PCB, and the components. So maybe at system level, if it's for the plastic and so on, we have the information in the EECONE database. So we can directly assign the EECONE activities to the product. And after, when we go at PCB level, maybe if we use some of the standard substrate and ink and so on, we have this information still in the EECONE database, so we can still assign activities. And if we go maybe at a component level, this time, that's where we get some limitation, and we don't have this information. But like you mentioned, if we have other partners that can provide this information, we can have a proper assessment of the global. That's why it's important that we have system PCB and that we cover the completely holistic approach of the system and PCB. It's a multi-domain and multi-level challenge, but we have the benefits of being able to cover this in the same structure.
Absolutely. Yeah. Okay. Are there any more questions?
Okay.
Perfect.
So, well, maybe we can conclude on that. I would like to thank again all the speakers today and also Arnaud for the support, the technical support. I would like also to thank very much all the participants. I hope this webinar was interesting for all of you. And we plan to run several other webinars more specific and more technical over the project. And we will keep you all posted, of course, for when these events will be planned. Thank you again, and we wish you all a nice afternoon.
Thank you very much.
Bye-bye,
Thank
everyone.
you. Goodbye.
Everyone, bye-bye.
Bye bye.
Thank you. Bye.